Hello, my name is Darren Thomas. I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at geometric sequences and recursive formulas. So let's go ahead and get started. Now, we learned about what recursive formulas are in a previous video. And basically what it is that you take the prior term to determine the current term you're trying to figure out in a particular sequence. And so we talked about that when we looked at arithmetic sequences. Now, in terms of geometric sequences, we're not looking for differences between terms. We're looking for a ratio. In other words, a comparison of two consecutive values to figure out what what value to multiply them by. And I know I'm sounding really theoretical right now, so let me start by we're going to go through two examples. Let me share with you our first example so that when you can see it, hopefully it'll be clear. So imagine we have the following geometric sequence. And let's see here, 20.25 and then dot dot dot. All right, like that. So here we got 6, 9, 13.5, 20.25, and then we got our ellipses after that. Now, to find our ratio, and we haven't talked about exactly how to do this yet, but to find your ratio, you just take any two terms, but generally you take the second term over the first term, but as long as it's any two consecutive terms, it doesn't really matter. And you use these two numbers to figure out what your ratio are. So in our situation, our a sub 2 bars, our second value in the sequence is going to be 9. Our first value is going to be 6. And so that means that we're going to get 3 over 2, or you can also say 1.5. Either one is acceptable. Now, to develop your recursive formula, here is the format below. So you're going to have a sub n equals the ratio times a sub n minus 1. That's how it works. And so for our purposes, it's going to be a sub n. Our ratio is going to be 3 over 2 times a sub 1 n minus 1. And this is going to be for whenever n is greater than or equal to 2, like that. And of course, when you have a geometric sequence, you always have the initial term. So in our particular situation, a sub 1 equals 6. That's how it works out. So you can see this is not that complicated, but let's just do one more to make sure this is clear in our minds, and we'll conclude for this one. Okay, so here's our second sequence. We're looking at 2, 4 over 3, then it goes 8 over 9, then it goes 16 over 27, then dot dot dot, like that. And so this is what we have. And so we're going to go ahead and go through our same steps as last time. So we know our r is going to be a sub 2 over a sub 1. That means we're going to have, let's see here, 4 over 3 over 2. All right, so that's another way to write that is 4 over 3 divided by 2 over 1. And of course, when you divide fractions, you flip the second one. So 4 over 3 times 1 over 2. And so you end up with, let's see here, 4 over 6, which simplifies to 2 over 3. All that is review. That should not be surprising at all for anybody here. So basically all I did was that I had a fraction as my numerator, which is a little bit more complicated. So I wrote it out, simplified it by writing it in a slightly different manner here. So 4 over 3 divided by 2 over 1. That 1 there is just to make both of them fractions. You don't have to really put it. And of course, when you divide fractions, you flip the second one, find a reciprocal for the second one, and multiply straight across. We got 4 over 6, which simplifies to 2 over 3. And so if I had to write my final formula here for this recursive one, it will be as follows. So we got a sub n. Whoa, that's the wrong color. We got a sub n is going to equal 2 over 3 times a times sub n minus 1 for when n is greater than or equal to 2. And you can check this. So for example, let's say I start with this guy right here. So I do 2 over 3 times 4 over 3, and I get 8 over 9, and you can continue from there on. So it looks like this formula right here is going to work for us, given the condition that n is greater than or equal to 2. So there's not a whole lot to summarize here, but essentially what you have to keep in mind for a geometric sequence when you're trying to find the recursive formula is that, of course, you must know what your initial term is, and then you need to determine what your ratio is. And so you take any two consecutive terms and you calculate the ratio. So basically you put A2, A1, that's the easiest way to deal with it. You put the further along in the sequence number on the top, I don't know quite how to say that, and you put the, I guess you could say the younger number on the bottom, whatever, so A2, A1. The point is that this number should always be greater in terms of what sequence number it is. That's the point. And this one should be one less that value. That's kind of the way I'm trying to explain it. So A2 over A1, that'll give you your ratio, and then you plug that right in here for your R, and that's pretty much it. And then you can solve accordingly as you so desire. So I hope that this video was useful for you and made sense. My name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for watching. Take care.